What's up guys, it's Timon Fiaz and today's video is on AQA level chemistry paper 1 June 2019. Before I start with this video, I know I haven't been very consistent lately with my videos. My last video was one day and 19 hours ago, basically 2 days ago. And it's coming to a time where exams are closer than ever, right? So I really want to, upload as many videos as I can because after my chemistry exams, this channel, obviously, I think I'll still be posting, even after the exams, which is kind of crazy to say. But obviously, I won't be posting as much. So until May the 1st, at least I'm going to give myself 1st of April, 1st of May, I'm going to be uploading so many videos on this channel. Obviously, all these videos on this channel, chemistry related, so many videos, and inshallah, you guys find them useful as well. So, AQA level chemistry paper 1 June 2019, question 1. Born-Haber cycle classical question. Complete figure 1. CS solid plus half I2 solid. CS plus gaseous plus C minus plus I gaseous, the first ionization energy. Just be aware of if you've got 2 moles, remember to times it by 2. Use figure 1 and data in table 1 to calculate standard enthalpy of atomization iodine. This is the way I like to do it, is by setting enthalpy of formation, which is this part, and this is enthalpy of lattice formation, and you just need to know that part. That's formation, that's lattice formation. Enthalpy of formation minus 337 equals the rest, 79 plus x plus 376 minus 314, and then obviously I do have this minus 585. Yeah, so then I could then move to 585, and then you get, and then a bit of rearranging, and you get x equals 107, and that's your answer for standard enthalpy of atomization iodine. So just use what these values indicate about the bonding of cesium iodide. Purely ionic, purely/perfectly ionic, because if this is minus 582 and enthalpy of lattice formation for cesium iodide is minus 585, the actual one, that tells me it's purely ionic. Yes, it's off by 3, but I'm not going to talk about covalent character in that case, which I did make the mistake of. No, it's purely ionic/perfectly ionic. Show the reactions not feasible at 290 Kelvin. Delta S of products, entropy change, entropy of products minus entropy of reactants. Substitute that in, you get 11.3 joules. Then I know delta G equals delta H minus T delta S. Delta H, 337 kilojoules multiplied minus 1 minus temperature, 298 Kelvin. It tells me that. Delta S, this is the part where most students, I'm pretty sure, mess up, and that's why it's worth 4 marks. You need to convert it. Delta S is measured in joules. This is in kilojoules, so I need to divide that by 1,000, and then I get Gibbs free energy change in kilojoules multiplied minus 1, 334 kilojoules multiplied minus 1. And then I would finish it off by saying, as it is greater than 0, therefore reaction is not feasible. In order for reaction to be feasible, delta G has to be negative, but it's clearly plus 334, so it's not negative. Describe process of electrospray ionization. P dissolved. Obviously, I'm going to apply it to the question, which is in this case P, whatever that large molecule is. P is dissolved added to a solvent and injected through a nozzle / needle at high voltage, gains a proton. Equation P plus H plus arrow pH plus. What's the relative molecular mass of P? Here's a bit of your understanding. If this is electrospray ionization, I've added a proton. And this is 556. The relative molecular mass is just going to be 1 minus the proton. So 556 minus 1, 555. Calculate relative molecular mass of Q. So K equals a half mv squared. M equals 2ke over v squared. Velocity equals distance over time. I get the velocity, and I've already got the kinetic energy. I substitute it here. In here, m equals 2 kinetic energy, which is 2.110 by 10 to the power minus 15 over the velocity squared. M equals that in kilojoules. That's in kilojoules, right? It tells us in my question, m equals mass in kilograms. Kilograms, not kilojoules. Then I turn by Avogadro's constant. I get m equals this. But obviously, I want it relative molecular mass in grams. So then I do times by 1,000 to get 169. Say the meaning of term periodicity. The repeating patterns / trends of physical or chemical properties. The repeating patterns / trends of physical or chemical properties. Identify the element period 4 with the highest electronegativity value. BR. Identify the element period 4 with the largest atomic radius. K has the smallest number of protons and similar shielding as other elements in period 4. Name the property of arsenic through oxide describes the ability to react in these two ways. Amphoteric. Complete the equation for the formation of arsenic hydride. As2O3 plus 6 Zn plus 12 HNO3 arrow 2 ASH3 plus 6 Zn NO3 2 plus 3 H2O. Question 4 can't do. Haven't gone through all those tests and all of that. For transition metals, given the equation for this reaction, question 5 state rules sulfuric acid NaCl solid plus H2SO4 liquid from NaHSO4 solid plus HCl gaseous proton donor. The role of sulfuric acid in this reaction is a proton donor. Equation for this fumes of sulfur dioxide form 2HBr plus H2SO4 arrow SO2 plus Br2 plus 2H2O. Observation orange gas role oxidizing agent of sulfuric acid. Give the oxidation state of chlorine NaClO3 and NaCl. NaClO3 plus 5 NaCl minus 1. This topic always comes up, right? Not this one, but this definitely does come up as well. You know, all these test equations you have to memorize. First thing I would do if I was you, which I'm probably going to do as well, go through all the past paper questions on these, memorize all those equations, because more than likely they're going to reuse these questions, and if they reuse them, you've already memorized all the past paper questions on these equation questions. And then once you've done that, then actually go through the textbook, and then you also need to learn the observations, and my textbook, CGP textbook, doesn't have the observations, a lot of them, so then maybe ask your teacher, which I need to do as well, and then learn your observations. It might seem like a lot, but we still got around 2 months to do that, so yeah. And that definitely is at least 10 marks overall, all 3 papers, maybe even more. So guaranteed 10-15 marks just by learning some equations. That's pretty nice. So today in terms of redox, what happens to chlorine in reaction question 5.3, chlorine is both oxidized and reduced. You don't need to say that about the oxidation state, but I will always would, because sometimes these marks seem very specific. So formula of D, AgBr, silver bromide. Formula of E, Ag2CO3. Formula of S, CO2. F is really easy because it says bubbles of gas, always bubbles of CO2 gas. Ionic equation form E, 2Ag plus CO3 2 minus to form Ag2CO3. Equation showed conversion of D into G, AgBr plus 2NH3 arrow Ag bracket NH3 2 plus Br minus. Calculate percentage of copper by mass in alloy. First things first, don't be scared of this question, which is probably the hardest part to do, and then just work logically. So I want to calculate percentage of copper by mass. Copper, where's copper in these equations? Copper, there, Cu2 plus, right? In this case, what can I use in this information? Well, I can use this, the moles of this, S2O3 2 minus, and that would give me, so work out the moles of that, 9.80 divided by 1000 times by 0.0800. Amount of Cu2 plus, therefore, in 25 centimeters cubed is the same, 7.20 times by 10 to the power minus 4 moles. Then I wanted 250 centimeters cubed, 25 centimeters cubed, 250 centimeters cubed, times by 10, 7.20 times by 10 to the power minus 3 moles. Then I want the mass of copper, 7.20 times by 10 to the power minus 3 times by 63.5. Moles in mass over MR, mass is the moles, which I just worked out, times by the MR of copper, 0.457 grams. And then I want the percentage of copper by mass in the alloy. Now the alloy has 985 milligrams, so I need to convert it to grams by divided by 1000, 0.985, and then just do the mass of copper, 0.457 over 0.985 times by 146.4%. Advice for these kind of questions, get a highlighter and highlight like all the key details, and if you find a part, like advice, if you don't know what to do, just keep working out all the moles you can, because you'll probably get a couple of marks from there. So there's 2 ways student could reduce percentage of certain measurement of the volume of sodium thiosulfate solution using the same apparatus as the experiment. use more of the alloy, use a lower concentration of thiosulfate solution. You're applying this to the question, right? Two ways to reduce the percentage of acidity, but in this case, use more of the alloy, use a low concentration of thiosulfate solution. Say the role of iodine in a reaction with sodium thiosulfate. Iodine with sodium thiosulfate, it is an oxidizing agent. Give the full electron configuration of copper 2 ion. Yes, this is testing your knowledge on, do you know copper and chromium special rules you need to know electron configurations of and what happens. 1s2, 2s2, 2p6, 2s2, 3p6, 2d9. Explain why copper 1 iodide is white. It's got a full 3D subshell. Think about it. That's 3d2 ion. Copper 1. Well, that's when it's lost 2 electrons. So when it's lost 1 electron, that's going to be 3d10. So it's going to have a full 3D subshell, 3d10. Therefore, there's going to be no DD transitions possible. Therefore, cannot absorb white light. Full 3D subshell, no DD transition possible. Therefore, cannot absorb white light. Calculate volume. This much occupies this much. This much. This is a nice question. Very, very nice question. Just memorize your units and the most common one, centimeters cube, and all of that. So PV equals nRT. V equals nRT divided by P. N, number of moles, 5 over 253.8 or something like that. Times by 8.31 times by 185 plus 273. Divided by 100,000, and volume is measured in meters cubed. And I get that. 7.5 over 10 by 10 to the power minus 4 meters cubed. In this case, I want it in centimeters cubed. So then I need to times by a million to get 750 centimeters cubed. Now, there's just one thing I need to check. And that is the periodic table. Iodine is there 126.9. But it says iodine vapor 126.9, 253.8. Yeah, so iodine vapor, therefore, is going to be I2. So that's just mistake maybe you could make. So remember, iodine vapor is I2. It's not just I. It is I2. And then therefore the MR is going to be double of I. Calculate mass in grams of oxygen gas and equilibrium mixture. This one's a bit of a weird one, but you can work out the equilibrium mixture contains this much sulfur dioxide, find out the moles, 1 to 2 mole ratio. So once you work out the moles of sulfur dioxide divided by 2, then you can work out the mass of oxygen gas, moles mass of MR, mass is moles times by MR, 1.52. Calculate mole fraction of each substance at equilibrium, 0.15, 0.4, 0.57, 0.28. All you do is for, let's say, sulfur dioxide, 0.320 over 0.320 plus 1.20 plus 0.600. And the rest for the other SO2 and O2. Calculate the mole fraction, give the expression for equilibrium constant Kp, and then calculate total pressure. This one is a one I definitely want to show you guys because I've seen it before as well, I think. Maybe this is the first time, I don't know. But it's the idea that because Kp equals the partial pressure SO2 squared times by partial pressure O2 divided by partial pressure SO3 squared, I want to find the total pressure of equilibrium mixture. And I'm only given the mole fraction, temperature, and Kp. What I do now is first things first, I move everything to the left hand side. So that goes here. So it's going to be Kp times by is no longer the partial pressure of this. I'm using the mole fractions of these. So I'm going to use a sign called like this, just a sign like that. The mole fraction of SO3 squared divided by the mole fraction of SO2 squared times by the mole fraction of O2. It's really important you move this to the left hand side, divided by that, and then realize that is what the total pressure is equal to. P is equal to that. And then therefore, P equals Kp 7.6 times by 10 to the power minus 5 times by the mole fraction of SO3 squared 0.15 squared over the mole fraction of SO2 squared 0.57 squared times by the mole fraction of O2 0.28. Get the total pressure. Really important, this kind of question, because it can definitely come up, and you can see it's not that many marks. Like usually these, it is obviously 4 marks, still quite a bit, but usually the 5 maybe 6 marks, right? 4 marks plus testing. Do you know that? So working at mole fraction, that's easy. Generate equilibrium mixture Kp expression, but then in order to find total pressure, you move everything to the left, divided by that, that's the total pressure equal to, then use lambda, the mole fraction, and then substitute values in, and you get total pressure. Explain how this information can be used to deduce that forward reactions endothermic. Well, I can clearly see that Kp is higher at a high temperature. Kp is 7.62 10 by 10 to the power minus 5 at 1050 Kelvin. So Kp is higher at high temperature. Reason being, at higher temperature, more products are formed. Equilibrium shifts to the right / forward direction. Because if Kp is higher at a higher temperature, more products must have been formed, because Kp is the products of reactants, right? So more products in order to get a bigger value of Kp. So therefore more products are formed. Equilibrium shifts to the right / forward direction. So if more products are formed, equilibrium is going to shift to the right / forward direction. It is a bit of a weird one, but once you've done it a couple of times, you understand what this question's trying to assess. Deduce the units of Kp, calculate value of Kp. Now what you have to do here is use the answer for data from question 9.3. Well, Kp at 500 Kelvin, therefore it's going to be square root of 3.94 times by 10 to the power minus 4. And reason it's square root is because you can see here a half O2, just one O2, right? And then I'm going to do the square root of the units, well, pascals, then square root of PA to the power half. Draw a diagram to show the strongest type of interaction between two molecules of ethanol, C2H5-O, oxygen with the lone pair, two lone pairs of electrons delta negative, then the hydrogen positive. And you can see that hydrogen bonding between the electron deficient hydrogen atoms and the oxygen delta negative oxygen with the lone pair of electrons, two lone pairs of electrons, C2H5H delta positive. In terms of molecular force involved, explain the difference in boiling points. Hydrogen bonds between ethanol molecules, permanent dipole forces between methoxymethane molecules, hydrogen bonds are stronger intermolecular forces. These kind of questions are very free marks if you've done a bunch of them. It just wants you to state the obvious. Ethanol, hydrogen bonding, methoxymethane, permanent dipole forces between the molecules, and the hydrogen bonds are stronger intermolecular forces. Draw the shape of POCl3, P double bond O, ClClCl, tetrahedral shape. Draw the shape of ClF4 minus, ClFFFF, two lone pairs of electrons, square brackets, negative charge, square planar. Bond angle of ClF4 minus, well, because it's square planar, I now know it's 90 degrees. Because you have to memorize the bond angle as well. Pure water at 40 degrees Celsius, pH equals 6.67. Student thought that the water was acidic. Explaining the student is incorrect, because concentration H plus equals concentration OH minus. Concentration H plus equals 10 to the power minus pH equals 10 to the power minus 6.67. Kw equals concentration H plus times by concentration OH minus. Kw, however, now because I know that, equals concentration H plus squared. Kw equals concentration H plus squared. I've got concentration H plus square root. I get Kw. Use figure 4 to determine the value of Ka for propanoic acid at 25 degrees Celsius. Now, there was a method in the mark scheme, but there's also alternative method, and I think the alternative method makes a lot more sense, and therefore I was using that one, and obviously a lot more sense for you guys as well. So first things first, Ka. What is Ka? Concentration H plus A minus over HA, but in this case I'm going to use concentration H plus squared over HA. Now, in order to do this, I need to find out concentration H plus and the concentration of HA. Now, the good thing for me is that propanoic acid, the concentration of it, is given in the question. If we read it properly, 0.080 moles per d minus cube propanoic acid. That's that. So, All I have to worry about is concentration H plus. And I know concentration H plus equals 10 to the power minus pH. Am I given the pH? No. But I can read from the graph, the pH here is 3. So all I can say, and that's pure. That's when no volume of sodium hydroxide is added. Therefore, I can now use a K equals H plus squared over HA, because that's when it was pure, right? So therefore, I can assume H plus equals concentration H minus, equals concentration A minus. Therefore, concentration H plus is 10 to the power minus 3, because pH is 3, squared over that 1.25 times by 10 to the power minus 5. Suggestion indicates most appropriate for reaction. Question 9.2. 9.2. Look at the vertical part of the curve, and just by looking at it like this, I'd say 9. And yep, cresol-Phelan, that covers 8.2 to 9.8. 11.6 to 13.0, well, just look at that. 11.6, 13.0, that's outside the vertical part. That's not even, that's too high. So it definitely can't be that. And obviously, if you look at the other one, bromothymol blue, 6. Yeah, a lot of you probably aren't going to go for that. So this one's a pretty nice one. It's quite clear it's going to be cresol-Phelan. Okay, this second to last question, I'm going to go through it hopefully in detail. Assume prepared buffer solution by adding this much of a salt to this much of a weak acid HX and mix them thoroughly. Assume added this much potassium hydroxide buffer solution. Calculate pH of buffer solution after adding potassium hydroxide. For the weak acid HX 25 degrees Celsius, value of the acid dissociation constant Ka equals that. Give your answer 2 decimal place 6 marks. So first thing I'm going to always do, HA plus OH minus R A minus plus H12. Definitely when it's more than 4 or 5 marks, I'm going to use this expression 9 times out of 10. I know the concentration of HA, in this case the acid, 100 divided by 1000 times by this. Okay, so I get that. The moles, sorry. And the moles of the salt, 0.0136. Moles of salt, 0.0136. Right? Then the student added this much of potassium hydroxide, and this is going to cause some problems. If I'm adding this much to the buffer solution, what's going to happen? Well, these are hydroxide ions, KOH, right? So if I'm adding hydroxide ions, this is going to become 3 times by 10 to the power minus 4. But obviously then it's going to become 0, right? So I'm going to then minus 3 times by 10 to the power minus 4. And this is going to react with it. Because if I added 3.0 times by 10 to the power minus 4 potassium hydroxide, this is going to want to get rid of it. It's HA. It's going to oppose it. And with these questions, you're always thinking opposite, equilibrium, opposite. If I add something to this side, I'm going to subtract from this side, vice versa. So if I'm adding this much potassium hydroxide to the buffer solution, a buffer resists the change in pH. And how's it going to do that? Well, it's going to try to get rid of it then, right? It's going to try to get rid of it. So if it's going to try to get rid of that to get to 0, it's also going to get rid of itself. So 0.05 minus the amount of hydroxide ions added, which is minus 3 times by 10 to the power minus 4. And therefore, I'm minusing one thing on one side, I'm going to add on the other side. Now I've got the new equilibrium moles, and then I just substitute it in. So K equals H plus A minus over HA. H plus concentration H plus equals Ka times by the concentration of HA. And the thing is, the volume is 100 centimeters cubed. And moles equals concentration volume. Concentration equals moles divided by volume. And I want it moles per dm cubed. So what I'm basically saying is, moles of concentration volume. Concentration is moles divided by volume. So then I get this. I substitute my values in. And you get, you turn by 0.0497 over 0.0139. You get that pH equals minus log 10 H plus 4.30 to 2 decimal places. Above solution has constant pH even when diluted using mathematical expression to explain this. The idea of the ratio where concentration Hx divided by concentration of X minus therefore remains constant.